This is the fourth video in the Chemistry Key Skills series of tutorial videos. In this video, we will be looking over equations, including how to balance them. In this video, we will look at both word and symbol equations, and we will look at how to balance symbol equations. We will calculate relative formula mass using the periodic table, and we will explain the conservation of mass in both open and closed systems. Our big question today is to write a balanced equation for the neutralization reaction between magnesium hydroxide and hydrochloric acid. One of the major skills in chemistry is being able to write chemical equations. The whole point of chemical equations is to show us what happens during a reaction. This means that we will be looking at both reactants, which go on the left-hand side of the equation, and products on the right-hand side of the equation. For example, magnesium plus oxygen goes to magnesium oxide. This is known as a word equation. It doesn't show us as much detail as a symbol equation, but it does show us the overall chemical reaction. We can make this equation much more useful by turning it into a symbol equation. In order to do this, we need to look at the periodic table. So looking at our example of magnesium plus oxygen, magnesium is Mg, oxygen is O2. Putting this in, we have Mg plus O2. We're going to form magnesium oxide, which is MgO, so we can place this in as well. In order to balance this, which we will look at in more detail on the next slide, we will put a 2 in front of magnesium and a 2 in front of the magnesium oxide. We now have 2 magnesiums on the left-hand side, 2 oxygens on the left-hand side, and then 2 magnesiums and 2 oxygens on the right-hand side of our equation. In your exams, make sure you read the question carefully as to whether the exam board want you to write a word equation or a symbol equation for each specific question. Being able to balance equations is an essential part of chemistry. This basically means that we need the same number of atoms of each element on both sides of the equation. This will make sure that we haven't had any atoms appear or disappear. We balance the equation by putting numbers in front of the formulas where needed. We will look at the following equation. So we have sulfuric acid, which is H2SO4, and lithium hydroxide, which is LiOH. These will react to make water, H2O, and the salt lithium sulfate, Li2SO4. In order to first balance this, we need to work out the number of atoms of each element that we have. So we have 4 different elements present. We have hydrogen, we have sulfur, we have oxygen, and we have lithium. First of all, we will look at the left-hand side. On the left-hand side, we have 3 hydrogens. We have H2, giving us 2 hydrogens, and a 3rd hydrogen here. So we're going to tally those up as 3 hydrogens. On the left-hand side, we also have 1 sulfur, just this one here. We also have 5 oxygens. We have 4 oxygens here and 1 here. And finally, we have just the 1 lithium. We are now going to count them up on the right-hand side. So starting with hydrogen, we have 2 hydrogens. We have 1 sulfur, as we did before. We have 5 oxygens, 4 here and 1 here. And finally, we now have 2 lithiums. As we can see, we do not have the correct number of hydrogens or the correct number of lithiums. We're going to look at changing the number of hydrogens. We can't change anything within the formula, so we can't change the small numbers and we can't add small numbers within. What we can do is put big numbers before a molecule. We're going to put a 2 in front of the H2O. This now gives us 4 hydrogens on the right-hand side, as we have 2, times 2. However, we have also gained an additional oxygen. 2 times 1, we have now gained an additional oxygen. We now have 6 on our right-hand side. Continuing to balance, we now need to look at our number of lithiums. We have 2 lithiums on the right-hand side and just the 1 on the left-hand side. This time, we're going to put a 2 in front of our lithium hydroxide to double our number of lithiums. This now gives us our second lithium. However, we have also increased our number of hydrogens. We now have an additional hydrogen, so we're going to add this to our tally. Finally, we have also gained an additional oxygen. Once again, we will add this. If we now look at our numbers, we have 4 hydrogens on the left-hand side and 4 hydrogens on the right-hand side. That is now balanced. We have 1 sulfur on each side. Again, this is balanced. 6 oxygens, and finally 2 lithiums. We now have the same number of atoms of each element on both sides. So our finished balance equation is H2SO4 plus 2 LiOH goes to Li2SO4 and 2 H2O. In the exam, it's worth adding in the large numbers in pencil first so that you can rub them out if you make a mistake. Within chemical equations, it's important to say the state that each of the reactants and products is in. This means the physical state that it is existing in. There are 4 that you need to know. First of all, we have solid, which is shown with a small s in brackets. Second is liquid, which has an L in brackets. Thirdly, we have a gas, which is a G in brackets. And finally, we have aqueous, which is AQ in brackets. Aqueous means it's been dissolved in water. So, for example, we could have aqueous hydrochloric acid reacting with solid calcium carbonate to form aqueous calcium chloride, liquid water, and carbon dioxide gas. This allows us to show changes of state. There are a number of chemical formulas that are really helpful to know. We have very common molecules in water, H2O, carbon dioxide, CO2, ammonia, NH3, and methane, CH4, and the diatomic molecules. These are all gases. We have hydrogen, H2, chlorine, Cl2, oxygen, O2, and nitrogen, N2. You will also be expected to work with ions. We looked at ions in the previous tutorial, where we looked at the simple ions from groups 1, 2, 3, 5, 6, and 7. However, there are some more complicated ions you also need to know. These are ammonium, NH4+, nitrate, NO3-, sulfate, SO4 2-, hydroxide, OH-, and carbonate, CO3 2-. Knowing these before you go into the exam will help you answer ionic equations. You can also be asked to write ionic equations. This is just what is happening in the reaction, looking at the reacting particles only. To write an ionic equation, you look at the balance symbol equation and take out all of the aqueous ions on both sides. So, for example, calcium chloride plus sodium hydroxide makes the insoluble solid calcium hydroxide and the aqueous sodium chloride. We then need to split our compounds into their ions. As calcium is in group 2, it will form a 2+ ion. Chlorine, however, forms a 1- ion as it is in group 7. Sodium in group 1 forms a +1 ion, and hydroxide, as we've just seen, is a 1- ion. We only split the aqueous solutions into their ions. Calcium hydroxide as a solid stays as it is. This gives us the following for the left-hand side. On the right-hand side, we have the following. As we can see, we have some of the same ions present. As such, we can delete these. So we are going to remove our 2 Na+ from the left-hand side and our 2 Na+ from the right-hand side. And we can also remove our 2Cl- and our 2Cl-. This gives us an overall ionic equation of Ca2+ in aqueous form plus 2OH- goes to CaOH2 in the solid form. This just shows us the overall ions in the production of that solid. In an earlier video in this series, we looked at relative atomic mass. Relative formula mass is really easy. All relative formula masses is the relative atomic masses of each atom in the molecule being added up. For example, for sodium hydroxide, which is NaOH. This has 3 different atoms in it. We have sodium Na, oxygen O, and hydrogen H. First, we need to find the relative atomic masses of these. Sodium is 23, oxygen is 16, and hydrogen is 1. Simply, to work out the MR, the relative formula mass of sodium hydroxide, we're just going to add these numbers together. So 23 plus 16 plus 1 gives sodium hydroxide a relative formula mass of 40. Where relative formula mass can be a bit trickier is when we have brackets or small numbers involved. If we were to take calcium chloride, CaCl2, or magnesium hydroxide, MgOH2. If we take calcium chloride, CaCl2, we have 1 calcium, which has an AR of 40, and 2 chlorines. Each chlorine has an AR of 35.5. So we would do 40 plus 2 times 35.5, giving us an MR overall of 101. For magnesium hydroxide, MgOH2, we now have brackets and a 2 involved. That means that we have 2 times oxygen and 2 times hydrogen. The AR from the periodic table of magnesium is 24, oxygen is 16, and hydrogen is 1. So we would do 24 plus 16 times 2 plus 1 times 2. Alternatively, we can first add everything in the brackets to give us 24 plus 16 plus 1 times 2. This gives us an overall MR of 58. By making sure that you can accurately work out the relative formula mass, you can work out the relative formula mass for any size of molecule. Before carrying out any type of chemical reaction, it is important to be able to identify the hazards. There are 6 hazards you must identify within your GCSE. First of all, we have oxidizing. This means that it releases oxygen to the surrounding area. For example, hydrogen peroxide or liquid oxygen. Our second one is harmful. This means it can cause irritation, reddening, or blistering of the skin. Most acids and alkalis we use in the lab will have this symbol. A good example, however, is bleach. Thirdly, we have this one with a tree and a fish. This means it's a hazard to the environment, so it's harmful to organisms and to the environment. For example, mercury or copper sulfate. Next, we have flammable. This means it catches fire easily, for example, ethanol or petrol. The skull and crossbones means that it is toxic and can cause death by swallowing, breathing, or absorbing through your skin. Things like hydrogen cyanide. Finally, we have corrosive. This means that it can destroy material, including living tissue, for example, your eyes and skin. It will burn your skin and the table. For example, concentrated sulfuric or nitric acid. Within your exam papers, you can be asked to give a risk assessment for one of the practicals you need to know, making sure you're talking about the risks as well as the hazards of the chemicals. In all chemical reactions, mass is conserved. This means that there are no atoms destroyed or created during the reaction. It means that we have the same number and same types on both the left-hand side and the right-hand side, exactly what we were looking at earlier in terms of balancing the equations. A good way to measure this is to carry out an experiment in a closed system. This just means that the system has a lid on the top, or in this case cotton wool, to prevent gas from escaping. In this reaction, we have hydrochloric acid and calcium carbonate chips. When these two react, we see effervescence or fizzing, and we get the formation of calcium chloride, which will still be in solution, we get water, and we get carbon dioxide. If we started with 156.45 grams, as it shows on the scale here, then we would finish with 156.45 grams. This means that mass has been conserved. We have the same at the beginning of the reaction as we do at the end of the reaction. In some chemical reactions, it may look like the mass goes up or goes down. This is because it is taking place in an open system rather than a closed system. If the recorded mass appears to increase, this is because at least one of the reactants is a gas. For example, a metal reacting with oxygen to form a metal oxide. The end mass that you would record of the oxide would be greater than the mass of the metal. The difference in masses is the mass of the reacted oxygen. If the mass, however, appears to decrease, it's because at least one of the products is a gas and has therefore left the system. A good example of this is the thermal decomposition of a metal carbonate, where a metal carbonate becomes a metal oxide and carbon dioxide. Carbon dioxide as a gas is given off and is able to leave the system. If we were to measure the mass of this reaction before and after, we would see that the mass before appears greater. That's because some of the mass has left as carbon dioxide gas. Explaining why the mass appears to either increase or decrease is a popular GCSE examination question. Looking over what we've covered in this tutorial video, we have looked at both word and symbol equations, and we have looked at how to balance those symbol equations. We've calculated the relative formula mass using the atomic masses that we found on the periodic table, and we've looked at the conservation of mass in both open and closed systems. Our big question today was to write a balanced equation for the neutralization reaction between magnesium hydroxide and hydrochloric acid. This will form magnesium chloride and water. I want you to have a go at this equation now. First, we will write out our word equation. So magnesium hydroxide plus hydrochloric acid goes to magnesium chloride and water. Our symbol equation would be MgOH2, which would be aqueous, plus HCl, which is also aqueous, goes to magnesium chloride, MgCl2, plus H2O, which is a liquid. In order to balance this, we simply put a 2 in front of the HCl and a 2 in front of the H2O. That concludes this video on equations. In the next video, which is video 5 of the Chemistry Key Skills series, we will look at both moles and concentrations.